The Grand Experiment, page 40. There was only one way to find out, by asking. So that summer, on his own, in the evenings and on the weekends, John Snow went from house to house in South London, knocking on doors, inquiring how many people in each home had gotten sick and how many had died. Then he would follow up with an unexpected question. Do you know which company supplies your water? In the neighborhood south of the river, most people no longer got their water from public pumps, but had it piped in from the River Thames. There were two private water companies supplying that part of London, Lambeth and Southwark and Vauxhall. While Lambeth piped in water from a relatively clean part of the river upstream, Southwark and Vauxhall drew their water downstream from the main sewer lines, which poured the city's waste into the water. Would that difference affect who got sick? John Snow suspected it would. Significantly, there was no predictable pattern on the water supply system. One house might be supplied by Lambeth, while all its nearest neighbors got water from Southwark and Vauxhall. If John could show that cholera struck only the homes supplied with dirty water, it would be strong proof that miasma was not the cause. He hoped that his grand experiment would establish once and for all that cholera was spread through contaminated water. Before John could complete his investigations, the Broad Street outbreak began. Could he apply the techniques he had been using in South London and find the source of the outbreak and do it fast enough to halt the epidemic or stop it from spreading beyond Soho? He knew he had to try. The great debate, miasma versus germs. Today it seems odd that so many people, including most doctors, believe disease floated around us in invisible clouds called miasma. How did this idea get started, and why do people believe in it for so long? The term miasma comes from the ancient Greek word for pollution. Miasma was thought to be a poisonous mist or vapor, rising up from rotting garbage and organic matter. Even the word malaria, for instance, comes from the Italian malaria, literally bad air. By the 19th century, nearly everyone equated bad smells with disease. Even after scientists like John Snow and later Robert Koch, who in the 1880s was the first to identify the bacteria that causes cholera, proved that germs, not miasma, were the sources of disease, many people refused to change their opinions. Florence Nightingale, the founder of modern nursing, believed until the day she died in 1910 that miasma was the source of many diseases. And she championed cleanliness, hygiene, fresh air, and sunshine as ways to prevent and cure disease. Nightingale's emphasis on the importance of high standards of hygiene in hospitals has saved millions of lives. And she was right that there is a connection between poor sanitation and diseases such as cholera and typhoid, but the connection is germs, not smells. The search broadens. John marched up and down the street of Soho, taking samples from all the local pumps. He hoped he'd be able to identify some contaminant, but when he got the vials of water home, they all seemed to be clear. John wasn't easily discouraged. He took to the streets again, knocking on doors, asking the same odd questions. Has anyone in this house had cholera? Where do you get your water? Over and over, he heard the same answer: the Broad Street pump. There were a few places that had escaped the epidemic, but even these exceptions seemed to point back to the pump. Just around the corner from Broad Street, at 50 Poland Street, there had only been 2 deaths reported at the St. James Workhouse, a charity home for more than 500 of Soho's poorest men, women, and children. Why had the cholera hardly touched these residents, while killing so many of their neighbors? The answer was that the workhouse had its own well, right on the premises. The other location in the neighborhood that seemed to have been passed over by the epidemic was a brewery on Broad Street. When John Snow asked the brewery owner where his workers got their water, he learned they were given a ration of beer every day and drank that instead. By now, John was convinced that the Broad Street pump was the source of the outbreak. But there was one death he couldn't account for. Susanna Ely, an elderly woman living across town in the Hampstead Heath neighborhood, had died of cholera on September 2nd. The date put her right in the midst of the Broad Street outbreak. Yet, what could her connection to the Soho epidemic be? With a few more questions up and down Broad Street, John got his answer. Susanna's sons operated the Ely Percussion Cap Factory on Broad Street. Every day they sent their mother a jug of cold water, fresh from the Broad Street pump, because she insisted that Broad Street had the best tasting water in all of London. Susanna Ely's love for the water from the Broad Street pump had been fatal. Can you handle the truth? By Thursday, September 7th, more than 500 people had died in an area of only a few blocks. An emergency meeting of the parish council was called. Worried men in tall hats and dark suits gathered in the parish hall to see what could be done to halt the deaths and suffering. Just as they were agreeing that the burning sulfur in the streets to disinfect the air was the best strategy, a stranger sitting alone in the back of the hall asked permission to speak. The council members listened in astonishment as Dr. John Snow laid out the results of his door-to-door research. The council was skeptical about John's outlandish water theory. However, they reasoned that preventing people from drinking the Broad Street water could do no harm, and it just might do them some good. The next day, workmen were sent out with instructions to remove the handle of the Broad Street pump. The spread of cholera, which had already been declining in the neighborhood, stopped altogether. The epidemic was over. But the Soho Parish Council and the London Board of Health were not convinced that the contaminated water had caused the outbreak or that the well was a source of contamination. They asked John Snow to continue his investigation and report back to them. One man from the council volunteered to assist John with his investigation, but he wasn't an ally, at least not at first. Henry Whitehead was the new assistant minister at St. Luke's, the local church, and he was convinced that John's theory was just plain wrong. The picture comes into focus. Despite their differences, the shy doctor and the young minister made a good team. Henry Whitehead was just 29 years old, and St. Luke's was his first parish. He was full of energy, and he had already knew many of the residents of Soho by name. Day after day, he paced the streets, knocking on doors, trying to track down residents who had fled the neighborhood in the early days of the outbreak. He visited some homes of 4 or 5 times until he was satisfied that he'd gathered all the information he could. While Henry walked the streets, John spent hours every night in his study poring over the data they'd collected. Frustratingly, there seemed little left to learn. Then one night, John tried something new. He took his list of confirmed cases of cholera and transferred the information onto a map of the neighborhood. He drew a black bar for every case reported from each address. Soon there were clusters of black bars up and down the winding streets. He studied the map. Something was missing. John picked up his pen and marked in the locations of all the water pumps in the neighborhood. By the time he put his pen down, he saw that he had drawn a picture of the epidemic. The black bars radiated out from the Broad Street pump, thickest near the pump and getting less frequent farther away. He felt certain the map would make an impression on the council in a way his earlier lists and tables hadn't been able to do. But he still faced the problem. What could this map convince Henry Whitehead? The final clue. We'll never know whether John's map alone would have been enough to convince Henry Whitehead and the parish council, because almost the same time, Henry Whitehead uncovered the last piece of the Broad Street puzzle. One evening, sifting through the piles of documents that filled his study, his eyes landed on a single line that had until then escaped his notice. Death from exhaustion after an attack of diarrhea 4 days previous. It was little Frances Lewis's death certificate. Until now, Frances' death hadn't been considered part of the cholera outbreak, but Henry realized that she might have been one of its many victims. He was surprised that a young baby had withstood the illness for 4 days, when adults often died of the disease in a matter of hours. 4 days. That meant Frances was taken ill before any other cases were reported. He looked again at the death certificate to be sure, and noticed the address, 40 Broad Street, right next door to the Broad Street pump. Henry's hands, holding the death certificate, began trembling. His brain whirled, and at last making the connections that had eluded him and John Snow. Here was evidence of a case of cholera that had started 2 days before the general outbreak in the neighborhood, and it was very likely that the victim's diarrhea had been disposed of near the Broad Street pump, which was the connection between all other cases in the epidemic. Had Francis's cholera-laden diarrhea contaminated the water of the Broad Street pump and led to an outbreak? Henry got up. Despite the late hour, he knew John Snow would want to hear about his discovery. The next day, Sarah Lewis answered a knock to find two serious-looking gentlemen on her doorstep. They'd explain, to ask about her baby's illness. When had Frances first gotten sick? Where did the family get their water? Where did their waste go? Sarah showed them the cesspool opening at the foot of the stairs, where several times a day she had poured out the water she'd used for soaking the dirty sheets and diapers. Seeing that the cesspool was just steps away from the Broad Street pump, John and Henry knew they had found the source of the epidemic. Tools of the trade, mapping outbreaks. John Snow's map of the Soho cholera outbreak is still studied by students in epidemiology. John was the first to use maps to show how disease outbreaks are linked to risk factors in the environment. In the Soho epidemic, when the city officials saw how the cases clustered around the location of the pump, they realized that closing the pump could stop the outbreak. Today, epidemiologists map outbreaks using sophisticated software that allows them to track and predict the spread of epidemics through both space and time. Mapping disease outbreaks is more complicated now than it was for John Snow because of the way that travel has changed. In the 1800s, travel was slow. Maps of disease outbreaks tended to show ripples radiating out from a single point, like the waves spreading from a stone dropped in a pond. Air travel changed that pattern completely. Now maps of disease outbreaks show clusters appearing randomly across the globe. Shanghai, Brussels, Vancouver, Mexico City, and they look more like the burst of fireworks than ripples in a pond. But researchers have realized that there is a pattern to what looks like chaos. International travel today happens through a network of airports. Substitute the typical map of the world with a map that shows the flights between different cities, and the randomness of the outbreaks becomes more predictable, resolving into the same outward ripples as John Snow's original map. Tool of the trade, the shoe leather method. John Snow is now known as the father of epidemiology. Not only did he create the first map of an outbreak, he was the first scientist to systematically study the spread of disease, looking for patterns and possible sources. Previously, doctors only gathered anecdotal information from the patients they treated, and they didn't compare that information with data collected from healthy people in the area to look for similarities and differences. John Snow's method of going door to door in the area of the epidemic is now called shoe leather epidemiology, and it's still one of the most valuable ways epidemiologists have been collecting information.